examples from Europe. We've been working with companies to build very high quality data networks. And here's a little presentation to kind of give you an example of how it can be done with the help of private companies, so public-private partnerships, and which includes agriculture. Thank you. So we know the risks of weather. I won't repeat, what everybody else already said. It leads to losses, damages, losses of lives, and loss of livelihoods. One of the biggest problems that we see from our customers and med offices, and you mentioned it many times here, is the lack of trained personnel to maintain weather stations. You train them, they stay for a year or two, they leave, you have to retrain them. And the way meteorological networks are built using complicated data loggers and systems, that's very good for a few weather stations where you need to put special sensors. But if you want to build dense networks in every microclimate, and you guys know about microclimates because on every island, you have many microclimates. It's not easy to build these networks using traditional weather stations. It's expensive and extremely hard to maintain. And therefore, you have few weather stations, which then leaves people in vulnerable communities exposed either to landslide risk or wind risk or whatever other climatological risks exist. So what we did, because we used to make weather stations like you see in all those wires, in the electronics. We used to make weather stations the classical way, data logger, sensors, blah, blah, blah. And then what we did was we decided to split this big weather station up into modules that makes sense to put together. You can measure air temperature, humidity, pressure together with solar radiation at 2-meter height. But wind, you shouldn't measure together with these things because when you put a wind sensor together with a radiation shield, you deform the wind by the wind sensor, by the radiation shield, you're going to get completely wrong wind measurements. And wind should be measured 10 meters up high, where you don't want to measure temperature, unless you want to do, variations, vertical temperature gradients. But then you want to measure also at multiple heights. So basically, we made a wireless wind sensor, which you can mount independently of the air temperature, humidity, and pressure measurements and solar radiation. And we also made a separate rain gauge, which is also, we have two versions, wireless and a wired one. And the rain gauges, obviously, you want to have as close to the ground as possible, where, just above the vegetation, so you don't get the wind air effects. And we made the system, to try to put it bluntly, try to make it people-proof, or sometimes I say idiot-proof. And I think we all know what happens, who has ever been installing weather stations. As much as you try, when the weather is not ideal, you're going to make mistakes. You cut the wire short, or you drop this expensive waterproof connector into a puddle of mud, and you put it back and seal it, and suddenly your waterproof weather station has water inside. Water inside the box condenses, evaporates in the sun and night. And then in a few months, your beautiful, expensive weather station is corroded and not functioning. So we closed all the electronics away from people. It's magnet operated to turn it on. And basically, what you do is you just take it to the field. You turn it on in the office, check data is coming, take it to the field, install it in 15 minutes, just put the bracket on a pole, mount the weather station, mount the sensors, and go to another site or back to the office. And this cuts a lot of costs out of installation, out of the life cycle of the weather stations, and a lot of errors of installation errors. So basically, it makes the installations, you can have students do it. Low-cost labor, basically free labor, students, right? And and then they just verified with a photo that they installed it. This is the meteorological network that's been built in Germany by one of our customers. It has 735 or 785 weather stations, a lot. It's class 1 siting, WMO. It's actually higher quality data than the German Met Office has. Because all the weather stations that they built over the years now have houses built around their weather stations. Population density has increased. And so their measurements are affected by this. When you combine, make a partnership with agriculture, you get a big synergy going. Agriculture, farmers have land. They can maintain the land around the weather station as long as you give them incentive. And then you can, where you give them forecasts or you give them data for pest control, for plant disease management and stuff like this. With the insurance companies together, parametric insurance especially, in this case, the parametric insurance company buys the weather stations. They either sell it to the farmers or install it, rent it to them. Farmer takes care of the weather station. They get a quick payout if it's parametric insurance. They have the parametric insurance, so the benefit for them is if there's a crop damage, they get immediate payouts because they have sensors on site. If the Met Office buys the data, or they can do a barter with the insurance company for the data, they can do more accurate weather forecasts for the farmers. And there is a lot of synergy going on with farming and meteorological departments and insurance, especially in climate vulnerable countries. And this works basically economically. This works. It's a private company, private insurance started this, and everybody is benefiting from it. Cannot move the slide. Thank you. And basically, yeah, this is what I just said. So there's many benefits for farmers from frost alerts, not in the Caribbean, but in South America, like Colombia, there's frost problems, potato damage, and many other countries that are situated up higher. Plant disease risk is always an issue, and irrigation is an issue everywhere. As the climate warms up, rain patterns have changed, and rain is more intense and more localized, and very unpredictable. So having rain gauges on the fields for the farmer on each field is very important, because it can be raining here, but 10 meters from me, they may not get any rain. One of the wireless technologies that we use and the sensors that we built, they're based on LoRaWAN wireless, hard to pronounce, sorry. It's basically, to make it easy to understand, you have one gateway that can receive data from many sensors. It's connected to the internet, and all the wireless sensors, they send out data. It receives the data and forwards it to the internet and to the customer's systems software. What this enables us to do is, if you don't have GSM coverage, but you can get the gateway on the edge of GSM coverage, then you can create 300 square kilometers, basically 10-kilometer radius coverage outside of your cell phone coverage of wireless weather sensor coverage, basically. So we're able to create wireless sensors and wireless coverage even when there is no GSM. Maybe from satellite, you can get internet to the gateway, and then you can, anywhere on Earth, create 300 square kilometer radius line of sight from the gateway of where you can put these sensors. And each of those sensor modules, you can see there is one meteohelix, which measures temperature, humidity, pressure, solar radiation. You can have each one of those modules independently wherever you need it. You can measure wind in 10 places. You can measure rain gauge at 20 places. You can measure temperature at 2 places. And you're not stuck building a whole weather station at each place. So that means you save a lot of costs, and you're actually optimizing your network to your weather patterns, to your vulnerable communities. And you're not compromising data quality, because all these sensors meet WMO accuracies. And as I mentioned earlier, if you mount the wind sensor at 10 meters, you don't want to measure temperature at 10 meters in an all-in-one weather station. You know, standard is at 2 meters for temperature. So, you know, why compromise when you can do it right? And we have, you know, basically we covered the basic parameters with our sensors from, you know, the wind speed, temperature, humidity, pressure, solar radiation. We have soil sensors. We have an agriculture module. And we're working on a water level sensor and even an evaporation pan sensor, wireless, so that these can be integrated also. Next slide, please. Okay, sorry. So the costs of maintenance of these networks. So we have actual data now after years and years of running this with the German insurance company. And the cost of maintaining 735 weather stations was 22,000 or 23,000 euros per year, which is extremely small if you imagine that the cost of sending a technician 300 kilometers or 100 kilometers back and forth is inside this number. And this is a game changer for many, many Met offices which are struggling with maintenance of meteorological networks. You can fill in the gaps in between your large weather stations with these micro weather stations and get WMO quality data, maybe even better data for the basic parameters than your actual weather stations from these stations, because you can have them on WMO class 1 sighting with the help of farmers, and you can have them everywhere. Over the life cycle of 10 years, you'll have 2 to 3 times lower costs than traditional weather stations. So, yeah, back to the accuracy. So one of the things that enables us to do this and to cut the costs is the interchangeability between the sensors. This cuts maintenance to the point that you take one of these weather stations, this is all weather stations, the metal helix, and if you have one that's, let's say, failed in the field, you give a new one to the technician, he goes there, swaps it one for one, takes that one to the office. There you can take it apart in a clean environment. He doesn't have to open any data logger boxes when it's raining or windy or whatever. And the exchange takes 15 minutes. You barely, basically, and then the cost basically of the maintenance has dropped significantly. The risk of finding something in the field where you have to spend another day diagnosing it is gone. The other thing is that if you need to recalibrate them, they have a removable sensor head, filter cap, just like everything else. You can do it the same way. You can do swaps of weather stations. You take a new one, put it in the field. I take the old one you want to recalibrate to the Met office. You take the sensor head out, recalibrate it. You take that one to a different place. And just on the portal, on the web, you just switch. In the Meteo Gardens we have, it's a software feature. You just basically tell the software, aha, you replace this station with this one. And due to the accuracy of the overall measurement, there's very little risk of having a step change of measurement because most of the weather stations are very, very consistent. So this is kind of a new way of thinking of doing maintenance, doing weather network building, and you know, it's been proven in Europe. So we can see, you know, as you saw the costs. Oh, here's a video, I forgot. Okay. Let's move on. Okay. Because of time. So this is an installation near, I think, Danube River. You know, it's very simple installation, and you can, and oh, excuse me, it's not working. Oh. And basically, the point is that you can install them anywhere very easily. If they get vandalized or stolen, that's an issue some places. It's not a huge deal because the cost of each of those modules is quite affordable because you don't have to build a whole big weather station, right? The other thing is, the good news is that in the next, let's say 6 to 12 months, each of these will have GPS in it. So even if somebody steals it, they're gonna get caught. So there has been, I found this study, which is interesting, and that's why I put it on the slide. It's about the use of weather stations by farmers and to help adapt to climate change. I think it's a very nice read and very good study. Actually, they didn't use our weather stations. I think they used Davis, but the concept is nice. It's called climate smart agriculture. And basically, they're monitoring the microclimates of different farmers that that plant coffee, and trying to figure out whether into the future the coffee farm will be sustainable, or whether they should start switching to different crops because the climate is changing, and identifying more vulnerable communities so that people can maintain their livelihood. And they're using weather stations to basically get hard data on how the climate is changing in each of these communities that are affected by climate change. Let's go. Okay. So in conclusion, basically, our system, our weather stations, we designed them to be scalable, to require very little network maintenance, because those are the problems that all Met offices face now. And obviously, the denser the network is, the better you can create and more accurate alerts you can create for people. But this is only possible if the maintenance and the installation costs are within reach of the meteorological offices. And I believe, we have a product here that's achieved that goal. And as you saw before, the operating budget for the maintenance of the network is quite small compared to maybe what you're used to. Oh, did I go skip a slide? So basically, again, it's proven technology, measures to WMO standards, very consistent measurement between the devices, so they're interchangeable, which enables this maintenance model to work. And for Met offices, think about building networks with farmers. It's an ideal situation, ideal synergy, and if you get an insurance company into it, then it's an even financially viable solution that works by itself. And here's just a little video. I don't know if it's going to go, of the mechanism inside our rain gauge, because our rain gauge is this is over 2,000 millimeters of rain per hour, which somehow got into the specifications of the Class A rain gauges. And I'm not sure if nature can do this. I know a cow can do this if it pees in a rain gauge, but I don't know why these numbers get into specifications, because this is something that nature doesn't do. But as you can see, it doesn't stop the mechanism from working. And I think this may be the only rain gauge that's able to measure whatever you throw at it. Obviously, there is water splashing out because these rain rates are ridiculous. But with the normal rain rates, you'll be able to measure everything within Class A and very accurately measure the rain intensity, because the tipping bucket moves so fast that it has very little loss. So, but that's just a little side note about the extreme requirements of the WMO, which sometimes don't make real sense. So, thank you very much for the time, and any questions? Go ahead.
Thank you. Just wondering, at what intensity do you have none of this splash loss?
This, like up to 600 or more. I don't know off the top of my head, but this was, yeah. Usually up to basically it's the rain gauge design is up to 600 millimeters per hour, which even that is very, very rare. It can do more, but obviously as you get higher, then it has splash. Up right now, if I remember correctly, At 600 millimeters per hour, without any correction, the underestimation is only 6%, which to any equivalent that I saw data sheet of any other tipping bucket rain gauge, 6%, they have underestimation at about 150 millimeters per hour. So we are about 4 times better with this design. The only drawback, and I'll openly tell you guys about this rain gauge, is the fact that the funnel is very shallow. It was an intentional design because it was designed to be compact and for a lot of agriculture, but we will have a deeper funnel. Obviously, when you have big rains, splash is a concern, right? But at the same time, when you have a lot of winds, the big funnels, they can have a lot of losses due to the internal spinning of the air and the little droplets coming out. So, and the funnel was designed also for a lot of places that have a lot of fog and you get a lot of horizontal precipitation. Because a flat funnel like this, you actually capture more of the little droplets when you have drizzle rather than a big funnel. Big funnel, the air speeds up above it. And so all the little droplets that are flying in the air, they come and go over it, and you miss a lot of it. With a flat funnel, you can catch more of this basically drizzle precipitation, which a lot of coastal areas, you get a lot of moisture into the soil from moving fog and drizzle in the air, where you have cold water and hot lands. So, any more questions? Everybody's hungry, so let's go eat.